Thank you very much for the all speakers and the audience. This is conclusion remarks. Sorry. Next slide. I cannot find out. Okay, yeah, sorry. So as you know, the dark matter is the most promising gate beyond the standard model of the particle physics and also the standard model of the cosmologies. So currently we have four types of the experiment. So for example, the direct detection experiment and indirect detection experiment and artificial production using accelerator and also the astronomical observation. So these collaboration is very crucial. And collaboration, coherent work is necessary to identify the dark matter and study of the particle properties and explore the early universe and histories. So this is a motivation of this workshop from the last years. So now we have exciting times. As you know, so the exciting excess is observed from the xenon 1-ton experiment here. Exactly speaking, I'm not yet convinced, but very exciting now. But so big effort to confirm that this excess is in progress in these workshops. And the other approaches, for example, using magic and also the GEO, the blah, 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 is also performed now, so very exciting. But I think we need more effort to study for the particle properties. Currently, just focus on the axions, but I think we have to also consider for the other cases. For example, so for the source is of this excess is the dark matter or the solar action case. In this case, such a mediator search is crucial. So the LHC and beam dump experiment is performed for the search for these mediators. But also not only the accelerators, but also the atomic physics can be used. For example, also positronium. The also positronium is a bound state of the electron and positron, whose spin is just equal 1. So it is the same as the photons, virtual photons, or decay into the gamma plus such mediators. 30 years ago, I performed such experiment when I was an undergraduate student. So positronium decay into the gamma plus somethings. And we have no excesses observed in such exotic decays, and we can obtain the limit of the coupling between the electron and the mediator is 10 to minus 11. This figure shows this line shows in order to explain the excess of the xenon 1-ton using these diagrams. So this is interesting regions. So using this experiment for this new region can be excluded. Of course, there are still interesting region is remained. So as I want to say, if the excess is confirmed, more new ideas, including not only the accelerators, but also the atomic physics and optics are necessary. And second things is many new researches will start it now, so including introducing in these workshops. CTA and STK and Geo600 and blah, 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 blah. So dance is also very interesting experiment. And also the future plan is LAX LZ xenon n-ton experiment is proposed. So the next step, what is obtained? We have to consider what is obtained when these results are integrated. Integration of these results is very important. So this is a homework for the next workshops. So the next years. So I'm not sure, but date is not also decided, but next will be also, we have also the workshops. And I want the face-to-face meeting maybe everybody is hope to the face-to-face meetings. In Japan, the autumn is the best season, and the weather is nice, and also the food is delicious. So let's see again in the next year in Kashiwas. Thank you very much for everyone's.